Hey you guys, this is Mr. Millings, and in this video we are going to learn about precipitation reactions. So what are precipitation reactions and how do they work? Well, it says right here that a precipitation reaction is a reaction in which the formation of a solid is the primary driving force. So the reason why these reactions even take place is because a solid can be produced. Okay, essentially a precipitation reaction occurs when two or more aqueous solutions are mixed together and produce a new insoluble solid substance known as a precipitate. So what the heck does this mean here? Well, let's take a look at an example. We have lead 2 nitrate here, and it says it's AQ. That means aqueous. That means that this lead 2 nitrate has been dissolved in water. All right, and we're going to mix this with some potassium iodide that has also been dissolved in water. It's aqueous. And when you mix these two aqueous solutions together, what ends up being produced over here is a solid insoluble mass, right? This lead 2 iodide does not stay dissolved in water. It's insoluble. It precipitates out. So this right here, this lead 2 iodide is called your precipitate. This is your precipitate. And what else is being formed or produced over here will be potassium nitrate that stays dissolved in water as well. Aqueous means dissolved in water. So anytime you have two aqueous solutions reacting together to produce a solid material over here, you have what is known as a precipitation reaction. And if you take a look right here, this little picture shows you the result of this chemical reaction right here. When you take two clear solutions of lead 2 nitrate and potassium iodide and you mix them together, this yellow substance starts to appear in this test tube right here, and this yellow insoluble solid substance is your precipitate. This is your lead 2 iodide right here, right? Your lead 2 iodide will be your precipitate. All right, so that's how precipitation reactions work. Anytime you have two aqueous solutions producing a solid material over here, you have a precipitation reaction, and it is the formation of a solid that is the primary driving force behind this reaction taking place. And so when we're dealing with precipitation reactions, it's always important to have out a solubility table that shows you the solubilities or insolubilities of these different compounds in water. So make sure you have a solubility table out like the one you see here. Make sure you have your periodic table of elements out so you can write the chemical formulas. And so now let's take a look at a precipitate and how precipitates are formed on a microscopic level. So what is a precipitate? Well, like we just said, a precipitate is a solid insoluble mass that can form when two aqueous solutions are mixed together. And in order to determine what the precipitate that forms will end up being, always be sure to refer to a solubility table. So let's take a look at an example here. We have a beaker here, and in this beaker we have a solution of silver nitrate. Now silver nitrate is an ionic compound. We talked about ionic compounds in an earlier video, but essentially an ionic compound is a compound in which you have a positive ion bonded to a negative ion. And the fact that it says it's aqueous, it's AQ here, means that when you put this in water here, it's going to dissolve. But what happens to ionic compounds when they dissolve in water, when they're aqueous, is that they have a tendency to dissociate. They will break apart into the ions that make them up. So when you put silver nitrate in water and it dissolves, it's going to break up into a bunch of free-floating silver ions and a bunch of free-floating nitrate ions. So in this beaker here, on a microscopic level, AgNO3AQ is going to look like this right here. And if we take a look at potassium chromate, we have another ionic compound right here. And when we put this in water, it says it's aqueous also. It's going to dissolve in water. So what ends up happening is that this is going to dissociate too, right? This ionic compound is going to dissociate, it's going to dissolve, and it's going to break apart into potassium ions and chromate ions floating around in this solution. So what ends up happening when you mix this beaker with this beaker here is that a solid insoluble mass over here is produced. And what is this solid insoluble mass? Well, what ends up happening is that the silver ions from over here are going to bond with the chromate ions from over here to produce this insoluble mass that no longer stays dissolved in this water. And this stuff is your precipitate. This is your silver chromate that does not dissolve in water. And if you look at a solubility table, you will in fact see that silver chromate does not dissolve in water. This is your precipitate, right? The silver chromate is your precipitate. So what else are we going to have floating around in this water right here? Well, we're going to have free-floating potassium and nitrate ions. This says it's AQ. So anytime this is AQ and you have an ionic compound, these guys here are just going to be free-floating in this solution right here. You'll have a bunch of potassium ions and a bunch of nitrate ions. So that is what's going on a microscopic level. That is how precipitates form. All right, so now let's take a look at how we can start to predict the products of precipitation reactions using a solubility table. So we're going to predict the products of a precipitation reaction, and the thing that you need to know first is that most precipitation reactions look like either double replacement or single replacement reactions. And we talked about these types of reactions in an earlier video. I suggest that you go ahead and click that little card that just appeared in the top right corner to review the different types of chemical reactions: synthesis, decomposition, single replacement, double replacement, and combustion. But for now, understand that precipitation reactions have a tendency to look like single replacement or double replacement reactions. So if we take a look right here, we need to predict the products of the precipitation reaction. So we have silver nitrate dissolved in water reacting with potassium chloride that's been dissolved in water. And so we need to predict what the precipitate that forms will end up being. So keep in mind that these are ionic compounds. Silver is +1, nitrate's -1, potassium is +1, chloride's -1, and that positives and negatives attract one another. So if a chemical reaction were to take place here, this positive ion is going to want to bond with this negative ion to produce AgCl. And this positive ion is going to want to bond with this negative ion here to produce KNO3. And so now what we can do is we can look at our solubility table. We can go to potassium and scroll on over or move on over to find nitrate. And we'll see that it's AQ. It does not dissolve in water. I'm sorry, it does dissolve in water. This stuff is aqueous. It will dissolve in water. However, if we take a look at silver chloride, we'll take a look at silver and go over to chloride right here. We see that this stuff will not dissolve in water. So when you mix these two chemicals or solutions together, will a chemical reaction take place? Yes. Why? Because a precipitate forms. And what is that precipitate? It's your silver chloride. Let's take a look at this one right here. We have iron 3 nitrate reacting with sodium hydroxide in solution. So the two possible products that can be produced here will be your FeOH3 and your NaNO3. Those are the two possible products. If we take a look at our solubility table, it says that this stuff here, sodium nitrate, will stay dissolved in water. But if we take a look at iron 3, here's iron 3, and go over to hydroxide, let's see here. We can see that that is not going to dissolve in water. So this stuff will be your precipitate. So will a chemical reaction here take place? Absolutely. Let's take a look at this one. We have aluminum sulfate in solution with barium chloride. So the two possible products that can be produced here will be AlCl3 as well as BaSO4. So if we take a look at our periodic table here, aluminum chloride, that says it dissolves in water, that's aqueous. And if we take a look at barium sulfate, here's barium right here, we're going to slide over to sulfate. It says that this will not dissolve in water. So barium sulfate is going to be your precipitate. Let's take a look at this one right here. We have HI in solution with zinc nitrate, right? So if we take a look here, the two possible products of this chemical reaction will end up being ZNI2 as well as HNO3. HNO3 is nitric acid, and this will always be dissolved in water. But let's take a look at zinc iodide. Here's zinc right here. Go over to iodide, and this too is AQ. So will a chemical reaction end up taking place in this one? We have two aqueous solutions. No solid is produced, so no reaction here will end up taking place when you mix these two together. Let's take a look at this one right here. We've got calcium chloride in solution with sodium phosphate. The two possible products here will end up being calcium phosphate and sodium chloride. which is table salt. We know that sodium chloride dissolves in water from prior experience. And if we take a look at calcium and go over to phosphate here, we'll see that that does not dissolve in water. So the calcium phosphate will be your precipitate. And yes, a chemical reaction takes place here. Let's take a look at this one right here. We've got lead 2 nitrate in solution with potassium sulfate. The two possible products that will end up being produced here will be your lead 2 sulfate, so PbSO4, as well as your potassium nitrate. Potassium nitrate, if you look on your periodic table, is soluble in water. However, if we look at lead 2 and go over to sulfate, we'll see that it does not dissolve in water. So the lead 2 sulfate will be your precipitate and a chemical reaction will take place. Let's take a look at this last one right here. We have sodium hydroxide in solution with magnesium chloride. The two possible products will be NaCl. We know that that dissolves in water, and we're going to have magnesium hydroxide. If we take a look at magnesium hydroxide, here's magnesium. We'll go over to hydroxide. Let's find hydroxide. It says it's insoluble in water. Whoops. Insoluble in water, right? It stays in the solid state. So a chemical reaction will end up taking place here. So that's how we can predict the products of a chemical reaction using our little solubility table. Let's take a look at a couple more examples that you can try on your own. Okay, so what I recommend you do here is pause the video and try this out on your own. Predict the products of this chemical reaction and use the solubility table here to determine if a chemical reaction will take place. So we have KNO3AQ reacting with NaOHAQ. And what we want to do is we want to figure out if a chemical reaction were to take place here. If a chemical reaction were to take place, the positive potassium ion is going to want to bond with the negative hydroxide ion. The positive sodium ion is going to want to bond with the negative nitrate ion, and we would end up with NaNO3. We can look at our solubility table and see that that will stay dissolved in water, and we will end up with potassium hydroxide. And if we take a look at potassium hydroxide, here is potassium right here. We'll slide over to hydroxide. We'll see that it is also aqueous. So will a chemical reaction end up taking place here? We have two aqueous solutions that did not produce a solid material over here. So no reaction. No reaction will end up taking place right here. Let's take a look at one final example. It says to predict whether a precipitation reaction will occur from the following reactants. If so, determine what the products will end up being. So if we take a look, we have NH42, CO3, ammonium carbonate that is dissolved in water here. And if we take a look, we're reacting this in solution with barium chlorate, BaClO3 We might run out of room here. And it says that this too is aqueous. Sorry about that. And so we need to predict what the products will be. Well, if a reaction were to occur, the positive ammonium is going to want to bond with the negative chlorate, and the positive barium is going to want to bond with the negative carbonate. For BaCO3, we can take a look at barium carbonate. Here is barium, here is carbonate. We can see that that is insoluble. And then the other product that will end up being produced will be NH4, ClO3. And if we take a look at our solubility table, here is ammonium and here is chlorate, and that too, that will be soluble in water. So will a chemical reaction take place here? We have two aqueous solutions producing a solid material over here. What is the precipitate that forms? That is going to be your barium carbonate. Okay, so yes, a chemical reaction will take place. Yes, a reaction takes place here. It's a precipitation reaction, and barium carbonate is going to be your precipitate. So that is how we can use a solubility table to predict the products of a precipitation reaction. If you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions down in the comment section down below. And I hope you guys found this helpful.